Welcome to another deep dive. This time we're heading way out beyond Neptune to the Kuiper Belt.
Oh, exciting stuff.
Right. I'm excited too. So think about it. This is a zone, a cosmic donut, really, packed with icy objects, dwarf planets, leftovers from when the solar system was first forming.
Really puts things into perspective.
Exactly. And we've got a couple of cool sources to guide our deep dive today.
Yeah. What are we looking at?
Well, NASA's official page, always a good place to start, right? And we've also got a great article from the Ad Astra space blog. It's called The Kuiper Belt, a deep dive into the solar system's icy frontier.
Sounds promising.
Yeah, lots of good stuff in there. So the Kuiper Belt, it's kind of like a giant cosmic archaeological dig, right?
I like that analogy, yeah.
Instead of pottery shards, though, we're uncovering these frozen relics, like billions of years old.
Frozen time capsules.
Yeah, exactly. And you know what? Let's start our tour with a celebrity.
Oh, okay.
Yeah.
Dropping names already.
Well, got to keep things interesting. But yeah, I'm talking about Pluto. Everyone knows Pluto,
Yeah, poor Pluto. Always getting demoted.
but still fascinating. Don't forget, it's a dwarf planet and a resident of the Kuiper Belt.
Right, right.
And remember that amazing flyby.
Oh, yeah. New Horizons back in 2015.
Gave us those incredible close-ups, the first real look at Pluto up close and personal.
And revealed another intriguing object even further out, Aerocoth.
Aerocoth, yes.
Hmm.
Such a weird shape, too, right? Like a snowman or something.
Yeah, like two icy pancakes stuck together.
Exactly. But Aerocoth, it's a great example of why the Kuiper Belt is so captivating. I mean, we're talking about potentially millions, billions even, of icy objects out there.
And we've only just scratched the surface.
Just a tiny peek. Most of them we haven't even seen yet.
That's what's so exciting. There's so much more to discover out there.
Absolutely. And they come in all shapes and sizes too, right?
Yeah. Hubble recently spotted the smallest Kuiper Belt object ever seen in visible light. Yeah, it's tiny, and that tells us something really interesting. It means these objects are constantly colliding and grinding each other down.
Oh, I see. Over time, I guess.
Right. It's a slow process, but over billions of years, it has a significant effect.
So it's not just a static collection of frozen stuff.
Nope. It's a dynamic, evolving environment, even if the changes happen on incredibly long timescales.
Cosmic timescales, right?
Exactly. And speaking of Hubble, did you hear about that observation in another star system?
No. What was that?
Well, they observed a shadow sweeping across a disk of material around a star. It's possible, potentially, it's an unseen planet shaping that disk with its gravity.
Wow. Like a cosmic puppeteer.
Exactly. And what's even more interesting is this disk, it's structured similarly to how we think the Kuiper Belt is organized.
Oh, okay. So an inner and outer region.
Yeah. Which raises the question, right? Could there be a hidden planet lurking in our own Kuiper Belt, shaping its structure?
That's a pretty wild thought.
It is.
Yeah.
And there's more. Remember New Horizons cruising through the Kuiper Belt?
Yeah, of course.
Yeah.
After the Pluto flyby, right?
Right. And they expected dust levels to decrease as they got further out. But
Yeah, it
instead,
happened.
they found higher than expected dust levels.
That's unexpected.
Right. It's a real head scratcher. So maybe the Kuiper Belt is bigger than we initially thought?
Oh, okay. Extends further out.
Or, and this is where it gets really interesting, some scientists are suggesting, hold on to your hat.
Okay, I'm ready. Hit me.
A second Kuiper Belt, even further out.
Whoa, a second Kuiper Belt. That just blew my mind.
Pretty wild, right?
And think about it. The Voyager probes, they passed through this region before we even knew it existed.
Yeah, back in the 80s. Amazing how much we've learned since then.
Totally. Voyager was focused on the gas giants, right?
Right. Jupiter, Saturn, Uranus, Neptune.
But New Horizons, that was purpose-built for studying the Kuiper Belt.
Yeah, designed to explore this icy frontier.
It's just incredible how much there is left to discover out there. But I've got a question. I mean, how did the Kuiper Belt even form in the first place?
Ah, the million-dollar question. Well, there are a few theories. One is that it's the remnants of what could have been a giant planet.
Hold on, are we talking like another Jupiter or Saturn that just never made it?
Yeah, kind of. The idea is that all the material in the Kuiper Belt, if it had all clumped together, it might have had enough mass to form another giant planet. But something stopped it from happening.
So what went wrong with this planetary construction project?
Well, scientists think Neptune's gravity is the most likely culprit.
Oh, okay.
Its gravitational pull might have prevented all that material from coming together into one big planet.
So Neptune's gravity playing the role of cosmic disruptor. Interesting.
It's one theory.
Makes sense, I guess.
Mhm.
But hold on, if the Kuiper Belt could have formed a giant planet, shouldn't there be more mass there?
You would think, right. And that's one of the things that puzzles scientists. The Kuiper Belt has way less mass than we'd expect.
So where did all the missing mass go?
That's where the NICE model comes in. It's a model that describes how early in the solar system's history, the giant planets, they weren't always where they are now.
Wait, so they weren't always in their assigned parking spots?
Nope. They migrated outward over time, kind of like a cosmic game of musical chairs.
Planetary musical chairs. I love
Yeah.
it. So this migration, how did it affect the Kuiper Belt?
Well, think about it. As those giant planets moved outward, their gravity would have flung a lot of the Kuiper Belt material outward too,
Oh, I see. Scattering it through the solar system.
and even beyond.
That's a pretty intense spring cleaning, huh?
Yeah, exactly. It explains why there's less mass in the Kuiper Belt than we'd expect.
It's like those giant planets just decided to toss out a bunch of the cosmic furniture.
Great analogy. And this migration, it also helps to explain some of the odd orbits we see out there.
Oh, yeah, like Pluto's wacky orbit, right?
Exactly. Pluto's orbit is highly elliptical, tilted compared to the other planets. That's likely due to those early planetary migrations.
So Pluto's wild dance moves are all thanks to Jupiter, Saturn, Uranus, and Neptune shaking things up billions of years ago.
That's the idea. It's pretty amazing, right? Those events from the early solar system are still shaping the dynamics of the Kuiper Belt today.
It really shows how interconnected everything is out there.
Totally.
I mean, the solar system is a wild and wonderful place.
And we're just starting to understand it. And speaking of Pluto's orbit, it connects to another cool thing about the Kuiper Belt.
Oh, okay, what's that?
Comets.
Oh, right. Comets. Those icy wanderers, they've fascinated people, well, kind of freaked them out too, for ages, right?
Yeah. And the Kuiper Belt, it's actually thought to be the source of a lot of those comets.
Really? So those bright streaks we see in the sky, those come from way out in the Kuiper Belt.
Well, not all of them, but the ones we call short period comets, those do.
Short period. So what does that mean?
Those are the comets that take less than 200 years to make one orbit around the sun.
Oh, okay. So like Halley's Comet, that's one.
Yeah,
Right.
exactly. Halley's Comet, it swings by every 76 years, and its orbital path, well, it points right back to the Kuiper Belt. Like, that's its home.
It's wild. Something we can see from Earth, from our backyards. It started billions of miles away in the Kuiper Belt.
It is pretty amazing. But then we have the long period comets.
Okay, so those take longer than 200 years.
Way longer. And they come from even further out, a place shrouded in mystery, the Oort cloud.
The Oort cloud. Okay, now we're talking serious distances.
We are. Picture this. It's like a giant bubble, a spherical shell made of icy objects, and it surrounds our whole solar system.
So like a giant icy halo around the sun and all the planets.
Exactly. And it stretches out really far. I mean, some estimates put it as far as 100,000 AU from the sun.
100,000 AU. That's what, like a mind-boggling number of miles, right?
It is. And to put it into perspective, that's about 1.5 light years away.
Wait, a light year? Isn't it the distance light travels in an entire year?
It is. And it's practically halfway to the nearest star, Proxima Centauri.
So our solar system has this enormous, invisible halo of icy stuff surrounding it, reaching almost halfway to another star.
It's pretty mind-blowing.
It is. It really makes you realize just how vast and empty space really is.
It does. And here's the thing. Those icy objects in the Oort cloud, they're like leftovers, primordial remnants from the very beginning of our solar system, just like the stuff in the Kuiper Belt.
So both the Kuiper Belt and the Oort cloud, they're like cosmic time capsules.
Exactly. They hold clues to what our solar system was like billions of years ago.
But here's a question. We've never actually seen the Oort cloud directly, have we?
Not directly, no. It's still a theoretical idea, even though, we have a lot of evidence pointing to its existence.
So how do we know it's even there?
Well, it's mainly because of those long period comets. Their orbits, they suggest they must come from somewhere really far out, and the Oort cloud fits the bill.
So it's like a giant jigsaw puzzle, right?
Right.
We have most of the pieces, but there's this one big chunk missing.
That's a great way to put it. And it just makes you wonder, what else is hiding out there?
I mean, the Kuiper Belt has already surprised us with so much cool stuff. Imagine what we might find when we can finally get a good look at the Oort cloud.
It's definitely a tantalizing thought. I mean, who knows what secrets are lurking out there in that vast, unexplored realm?
It's enough to make you want to build a spaceship and go exploring right now.
I know, right?
But until then, I guess we'll have to keep studying those comets and piecing together the clues they give us.
It's like a cosmic detective story, trying to understand the origins of our solar system and our place in the universe.
And the Kuiper Belt and the Oort cloud, They're key pieces of that puzzle.
Absolutely. They hold clues to the early days of our solar system, a time when planets were forming and everything was in flux.
It's amazing to think that those ancient events are still shaping what we see today.
It really is, and it just goes to show how interconnected everything is in the cosmos.
It's amazing, really, how much we've learned about the Kuiper Belt, especially with missions like New Horizons, gathering all that data.
Yeah, it's been a game changer, but like with every answer, it feels like we get 10 more questions.
It's true, right? It's like every time we peel back a layer, there's a whole new level of complexity.
Exactly. The universe loves to keep us guessing.
Speaking of complex, let's go back to that idea of a failed giant planet, the Kuiper Belt being the leftovers. If that's true, shouldn't there be, I don't know, like a core or something?
That's a good point. You'd think so, right? Like some massive remnant. But we haven't found anything like that yet.
So does that debunk the whole theory?
It definitely makes things tricky. It's possible maybe that core got disrupted during all that planetary migration.
Oh, right, the nice model.
Yeah, stuff getting flung around, scattered, or hey, maybe it never fully formed in the first place.
So still a mystery then.
For now, yeah. But it's fascinating to think, what if that giant planet had actually formed? How different would our solar system be?
Right. The orbits of everything, the gravitational pull, who knows? Maybe even moons around that giant planet.
Exactly. It's these little what-ifs that make studying the solar system so captivating.
Totally. But even without that giant planet, the Kuiper Belt's still pretty amazing, a time capsule, and it's still active, right? All those collisions happening.
Oh, absolutely. Those collisions, they release dust, and that's what New Horizons picked up, those higher than expected levels.
Right, right. So it's not just static, it's changing all the time, even if it's on a cosmic time scale.
Exactly. And those changes, they can have ripple effects throughout the solar system, even here on Earth.
Oh yeah, the comets, they're a pretty direct link.
Absolutely. Every time you see a comet streaking across the night sky, you're seeing a little piece of the Kuiper Belt. Or maybe even the Oort cloud.
That's mind-blowing. It really makes you feel connected to this vast cosmic web. So as we wrap up, what's the one big takeaway you want our listeners to, I don't know, walk away with?
I want them to look up at the night sky and just feel that sense of wonder, There's so much out there to discover, so much we still don't know.
It's humbling, right? And inspiring at the same time.
Exactly. And the Kuiper Belt is just one example. This incredible place right on our cosmic doorstep. It's a reminder that exploration, it never really ends.
Well said. Always new frontiers, new mysteries to solve. Thanks for joining us on this deep dive into the Kuiper Belt. And until next time, keep looking up.